All right, so now we're going to graph another line. All right, we're going to graph the line we're given, line FG, and then we're going to graph the line that is perpendicular to line FG through point A. All right, and this is in your notes, just under the problem we did in the previous video. So graph a line that contains A 2, 8, perpendicular to line FG, with F at -4, 1 and G at 2, 3. All right, so these are two separate lines. One is line FG, contains the points F and G, and one is a perpendicular line that contains point A. So step one, let's go ahead and we'll graph point A. So point A is at 2, 8. Right, so 2, 1, 2, 3, 4, 5, 6, 7, 8. Just fits. Step 2, we got to find the slope of FG. So we're going to use the slope formula. Take the difference in the y coordinates over the difference in the x coordinates. It does not matter which point we start with, right? But whatever point we start with, let's be consistent. And I'm just going to work left to right, so I'm going to start with point F. All right, so we have the y coordinate for point F, and actually just label these x2, y2, x1, y1. And it wouldn't matter if I labeled the first one x1, y1, and the second one x2, y2, and I started with x1, y1. So long as if I start with y1 in the numerator, I start with x1 in the denominator. That's all that matters, is that you match your points. You don't flip your coordinates. So we have 1 minus 3 divided by -4 minus 2. 1 minus 3 is 2. -4 minus, -2. 1 minus 3 is -2. -4 minus 2 is -6. The two negatives cancel, and matter of fact, this also reduces. So 2 and 6 are both divisible by 2. 2 divided by 2 would be 1, and 6 divided by 2 would be 3. And since both the numerator and denominator are negative, the two negatives cancel. It's like reducing by -1. All right, so this is going to be a positive 1/3. So that is the slope of line FG. But we are graphing the line that is perpendicular to FG. So remember, perpendicular lines have slopes that are negative reciprocals. So we got to flip it and negate it. So instead of 1/3, we're going to have 3/1, or just 3. And instead of it being positive, it's going to be negative. So the slope of the perpendicular line is -3. Right? So make sure, by the way, you're taking notes with me. I think what I have already written down is pretty much already written in your notes. What I'm writing down as I make this video is not in your notes, and you'll write that down as well. All right, so we have the slope now of -3, and we're going to use the slope to count from A and graph more points. All right, so I'm going to count. And you actually have in your notes, graph more points. But when I erased my board, that got erased too. So you already have graph more points in your notes. It's just me that doesn't. All right, so we're going to count down 3. Actually, let's just review. So our slope is -3, so -3/1 when we're counting, which means we have nowhere to count up, right? So this is our rise and our run. So while normally we could count up 3 and go to the left 1, if we count up 3 and go to the left, we're off the graph. So we're just going to count down 3 and to the right 1 until we run out of points. So down 3, 1, 2, 3 to the right 1. And down 3, 1, 2, 3 to the right 1. Down 3, 1, 2, 3 to the right 1. Oh, we can do it one more time. There we go. And we'll go ahead and connect our points. And let's see if I can draw a straight line. It's okay. I'll give myself, that's a little better. I'll give myself a C+ for drawing a straight line. All right, so there we have graphed the line that goes through point A. And you know what? Let's go ahead and label point A. So right here where I had the blue dot is point A. All right, and that point is 2, 8. That's the one point we know for sure that we were given. Of course, we have other points now that we've counted, but what we don't have is the y-intercept. So when we get to step 3 and we write the equations for our lines, we will be using point slope for writing the equation of the line that goes through point A. All right, so we have our perpendicular line graph. To kind of check, we're going to graph the other line. We're going to graph FG. And we have 2 points on this line, so we could do one of 2 things. We could graph one of these points or both of these points and use the slope to count out more points, or if they're reasonably far apart, we could just connect to the 2 points and not count out any more points. All right? Let's see how they look once we graph points F and G. So point F is at -4, 1. So that would be right here is point F. I'm just going to put F. And G is at 2, 3. And they're pretty far apart, right? But you know, I might want to get more points. Right? It helps me to have more points. Otherwise, I start to drift off and my line starts curving. So let's go ahead and count a few more points. So line FG has a slope of 1/3. And we are only going to count in one direction. I cannot count to the left of F without going off the graph, but I can count to the right. So we have a positive slope. So we're going to count up 1, that's our rise, and we're going to count to the right 3. And we'll count a few more points out. So up 1 to the right 3, 1, 2, 3. And up 1 to the right 3, 1, 2, 3. And you can see that those points are all on the same line, especially if you look at point G. Those are definitely on the same line from point G. So now we're going to connect, and let's see how I do. Oh, pretty good. I'm going to give myself a B for that line. All right, so now we have line FG graphed. All right, and the slopes of these lines we can see are negative reciprocals. We can see the points, right? And we can see that line FG has a slope of 1/3. And we can see that the line that goes through point A has a slope of -3. So those are definitely perpendicular lines. Let's go ahead and write the equations of both lines. And for both lines, we're going to have to use point slope because we did not count and land on the y-axis for either lines FG or the line that goes through point A. Neither one of them can we use the slope go right to slope intercept form, right? Otherwise, we're not going to be correct. We don't want our line to be incorrect. So we're going to go ahead and use point slope. Let's go ahead and write the equation of FG first, and I think actually you have that in your notes. So you have line FG written there. I'm going to put the little line symbol over it. And I did add the point slope form of the equation for our video. And actually I added it in yours too. I wrote it where I wrote perpendicular line. So you don't have to write it twice. It is already in your notes. So you're just going to write with me finding the equation for line FG. Now we have 2 points that we know for line FG. We have -4, 1, and we have 2, 3. And we can use either point, it doesn't matter. How about we use 2, 3? I've already got it labeled x1, y1 anyway, and I kind of like using positive values if I can. All right, so let's just use that one. All right, so the equation is going to be y minus 3 equals, the slope is 1/3, so 1/3 x minus 2. We'll go ahead and distribute, which means to multiply. Y minus 3 equals 1/3 times x is 1/3 x. 1/3 times -2 would be -2/3, right? If you put a little 1 under there. 1 times -2 is -2. 3 times 1 is 3. So this is just going to be -2/3. So now I need to add 3 to both sides. And I can't just add 3 on the other side, right? I need to have a common denominator. So I have to change 3 so it has a denominator of 3. Well, 9/3 is equal to 3. Notice that the missing value is the same as just multiplying the across, multiplying or counter, what you call it, diagonal. So if I want it to be in thirds, I just multiply the 3 times 3, because I would have to multiply 1 by 3 to get 3, so I have to multiply 3 by 3 as well. So it's going to be 9/3. And if I divide 9 by 3, it is indeed 3. So we're going to add 9/3 on the other side. And boy, my writing took a little while to pop up there. All right, so our equation in slope-intercept form for line FG is y equals 1/3 x. And -2/3 plus 9/3 is going to be 7/3. And there we go. And you can see it wasn't an integer value, so the only way we could find it is by using point slope. All right, I'm going to write point slope one more time just while we're finding it out. And come on, my writing is being slow again. And actually, I'm going to switch colors just so it doesn't all blend together. Y minus y1 equals m times x minus x1. And you already have that in your notes. So we have the equation for line FG. Now let's find the perpendicular line. All right, and we only have 1 point for the perpendicular line, and that's 2, 8. So 2 will be x1, of course, and 8 is y1. So for the equation of that perpendicular line, that would be y minus 8 equals, the slope of the perpendicular line is -3. So y minus 8 equals -3 times x minus 2. We'll distribute. So we have y minus 8 equals -3x. -3 times -2 is a +6. And then we'll add 8 to both sides. So we have y equals -3x plus 14. All right, and so now we have the equations for both lines. We needed to use point slope for both of them because for one line, the y-intercept was a fractional amount, which we would need point slope to figure out. And for the other line, it was off the graph. So we would also need point slope to figure out. Okay. As a reminder, our steps for graphing a line perpendicular to a given line. Here we were just given the points, but that's all we need. Number 1, we have to find the slope of the line we are given. Number 2, for the perpendicular line, we have to find the negative reciprocal of that slope. We have to graph our given point that is on our perpendicular line. In this case, it was 2, 8. And then we have to use the slope to count out more points. And then we connect the points. As a check, we can graph the line that we're given, F and G, or FG, line FG. And we can see once we graph the line that those are indeed perpendicular because their slopes are negative reciprocals. And then to write the equations of the lines, if we land on the y-intercept at an integer value, then we can write the equation in slope-intercept form, as we did in the previous problem. But if we do not land on the y-axis at an integer value, either because the y-intercept is a fraction, or the y-intercept is not on our graph, it's too big or too small, then we'll use point slope. All right? So thanks for watching this video, and bye for now.